Here's a example about solving equations by completing the square. We've done this before, so this is just kind of a review. We got x squared minus 6x plus 10 equals 0. Remember that the first step is to get rid of the 10, so we just have the x squared minus 6x over here. And once we do that, I'm going to have x squared minus 6x plus some number equals negative 10 plus whatever that same number is. Now I'm going to take the middle term, which is the minus 6. I'm going to take half of it, so I divide it by 2, and I get negative 3. And then I'm going to square that. This is the number that I'm going to be adding to both sides. So I will be adding negative 3 squared, which is 9, to both sides. Once I have now done that, my next step is to go ahead and factor this perfect square trinomial over here. It should break down into x minus 3 and x minus 3. Notice that that minus 3 is this minus 3 that was being squared. On the other side, negative 10 plus 9 is a negative 1. Now as we continue, x minus 3 squared is how we can write the left side. The right side is still negative 1. Now because this is now a square, I can now use my square root to undo the square. Whatever I do to one side, I have to do to the other. And remember, anytime you put a square root into the problem yourself, you must consider two possibilities, the positive possibility, the negative possibility. Now that I've done that, square root of x minus 3 squared is x minus 3. We can go ahead and get rid of the parentheses. On the other side, square root of negative 1 is I. So because of that negative, we're going to get an imaginary number out of the situation. And the square root of 1 is just 1. So square root of negative 1, we just get an I out of that. Now, almost done. We're to our last step. This is where we're going to end up with our complex solutions. My first solution, I'm going to add 3 to both sides, so that my first solution is 3 plus I, and my second one, if I separate it, is 3 minus I. Remember that complex numbers or imaginary numbers always come in pairs, and they should be conjugate pairs, which means, as we've talked about the last couple of days, one's going to have a positive, one's going to have a negative. Other than that, they're exactly the same. Okay. And this problem has now been solved. So take a moment, copy this down, and I will do one more example, this time with the quadratic formula. Okay, example 2. This time we have a quadratic. Solve 3x squared minus 4x plus 4 equals 2. This time I'm going to solve it using the quadratic formula, which is x equals negative b plus or minus square root b squared minus 4ac divided by 2a. When you're using the quadratic formula, remember that it must be equal to 0. So I need to move that 2 to the other side, so that we will have 3x squared minus 4x plus 2 equals 0. I'm choosing to use quadratic formula on this one because my a value is not 1. As you saw on example 1, the a value, number in front, our lead coefficient was 1, which makes it really easy to do completing the square. But when the a value is some other number that you can't factor out of all the terms, it makes it a lot more difficult to do the completing the square. So I'm going to use quadratic formula. Alright, so now I'm going to label my values. A is 3, B is -4, C is 2. Once I've done that, now I'm ready to plug in to my formula. So the opposite of B is a positive 4, plus or minus square root b squared. So we're going to take -4 and square it. Now remember, when you square this, you're squaring the negative as well. So this is going to come out to be positive. -4 times A, which is 3, times C, which is 2. All divided by 2 times A, which is 3. So now we're going to multiply. X is equal to 4 plus or minus -4 squared is 16. Take away 4 times 3 times 2. 4 times 3 is 12, times 2 is 24. All divided by 6. Finishing up what's on the inside here, we get X is equal to 4 plus or minus. This is the square root of a -8. And that's over 6. Now my next step is to go ahead and take care of that negative, and also to break down my 8 so that I can simplify the radical. 8 is 4 times 2, and 4 is 2 times 2. So I have a pair of 2's, and then I have an extra 2 that's left over. So this is going to be equal to 4 plus or minus that pair of 2's. When I have a pair of 2, I can take out a 2. The 2 that I don't have a pair of has to go back inside. And then to take care of that negative, I'm going to put an I on the outside. And all of that is over 6. Almost done. My last step is to now take and separate it and then reduce it. So I've got 4 plus 2 radical 2 I over 6, and 4 minus 2 radical 2 I over 6. What I'm going to do, because it needs to be done, I'm going to separate this actually into 2 pieces. Besides 2 answers, I'm going to separate it into 2 fractions. So I've got 4 over 6 and 2 radical 2i over 6. And then here I've got 4 over 6 minus 2 radical 2i over 6. So now that I've separated, I'm going to reduce those fractions. 4 over 6 is 2/3 plus 2 over 6. Now this is the only 2 right here that I can simplify with the 6. 2 over 6 is 1/3. You can put that little 1 there in front if you want to. It's not hurting anything if you do, but it's not necessary if you don't. And then, so my first answer is 2/3 plus radical 2i over 3. Make sure your I is outside of the radical. And then my second answer is 2/3 minus square root of 2i over 3. Again, this 2 and this 6 reduces down to 1/3, just like this 2 and this 6 reduce down to 1/3. The 2 underneath the radical cannot be simplified. You can't simplify something under a radical with something outside of it. Okay? These are my 2 answers. It is complex because I have a real part and an imaginary part. And once again, you see the conjugate pairs. One's positive, one's negative. Other than that, they're exactly the same. So if you were to multiply them back together, the i's would cancel out. Alright, go ahead and pause, finish copying down your notes, and then work on your problems, and we will see you tomorrow. Thank you.